Hey guys, welcome back to another video. Today we're going to be talking about how to use different AI and ML libraries and what to think about whenever you're using these AI ML libraries to train models and to solve problems. So today we're going to be talking about how to actually take these libraries, train a model, and then try to understand what the output is of said model. So I have a script here, and all we have is we're importing all the necessary pieces. I have not finished the script, so we're going to go over some of the pieces together. And there will be some parts, because I definitely get confused with some of the accuracy, precision, recall, F1. I can explain what these metrics mean, and then I can then kind of show you the formulas behind them. Sometimes they can get confusing because there's a lot of false positives to true positives, and or false positives over true positives and that kind of deal. But we'll get into all of that, and you'll understand hopefully by the end of this video. But the first thing we did is I actually went to Kaggle. So if you're not familiar, Kaggle is a dataset hub. It's also a model hub for finding easy ways to learn how to train AI and ML for certain problems. And this is a really, really good site for doing competitions if you're interested in that kind of thing. You can do competitions and actually win prizes, and normally those prizes are in cash. And people like Google and Amazon will sponsor those, and you can do that. But what I did was I pulled a data set. It's a diabetes data set. It's got a couple pieces to it. So we have the gender of the individual, the age of the individual, if they had hypertension, heart disease, smoking history. It shows their BMI. I actually don't know what this level is, but this is apparently something that's also measured. Blood glucose level. And then we have our truth, which is if they had diabetes. So given all of this data about the individual, what can we learn? Can we actually figure out if they have diabetes, and can we find out what pieces kind of come along with like their gender, their age? Like, is there a correlation, I guess is what I'm trying to say. And that's kind of something that you learn as you train the model. You may notice that there are certain columns that are more important than others. Maybe age isn't a factor when it comes to diabetes, which I think some people believe that is. So, and there probably is some study out there that may show a correlation. But there is a lot here that kind of plays a part in this. So, depending on your data set, you might have more columns, you may have less, but it's always a good thing to have a fair amount of data to logically use to solve problems. Coming from like a position where I work in AI and ML full time, and of course I always forget pieces as I go. It's just part of the job of doing software engineering and AI ML development. You don't always remember all the pieces and all the tools that you have at your disposal. But some of the things that do come along with you are kind of intuition on what to know and what to do. That was what one of my good friends told me was you kind of build intuition over time. And that's the most important part, because you'll always look up that random pandas function or that random Python package that you need to pull. And you may have done it 1,000 times, but at some point you'll have to look it up again and remember what params are there. But one thing that we can know is how AI and ML actually work when you're dealing with data. So for example, we know that you can actually train a model and get it a specific output and find correlations. And that's kind of the goal, is to make sure that we have enough data that makes sense to find correlations between certain things. And remember, when it comes to medical diagnosis and stuff like that, it is kind of hard because there's a lot of different pieces to the puzzle. Our bodies are very complex, and every individual is very complex. So this is kind of a difficult thing to solve, to find the correlation between diabetes. So it may be that this is more of detecting if somebody were to have diabetes based off of this data. So that's kind of the what we're looking for here. So let's get back into it. But what we have here is we have pandas. So that's going to be what handles our CSV file. And then we're going to have the train test split, which I'm doing right here. And for those that don't know, a train test split is how you split your data. The model will train on the train data. And you have a train, and then you have an X train and a Y train, and we'll see that in a moment, why that's important. And then you have your X test and then your Y test, and I'll show you why that's important as well. But first, let's start with the basics. First things first is we have the train and test. So our train and test, we have our X, which is our features, and our Y, which is our labels. So these labels are actually the diabetes column here. So we have our column that's just showing this is individuals that have diabetes versus don't. And I believe 0 is the people that don't have diabetes, and 1, they do have diabetes. So we'll probably see some sort of correlation here as we go forward. I do have the data set pulled up on another screen, so we can I can kind of follow along and see where the data is. But yeah, it says diabetes is the target variable being predicted with values of 1, and then indicating the presence of diabetes. So that's 1, and then we have 0 for none. So there is a small number of diabetes comparatively, and I'll actually pull it over for y'all to see. And I might have to go to a more generic view so you guys can actually see it, but essentially let me get a window capture here. Okay, there we go. So it might be kind of hard to see here, but basically we have the diabetes column, which is our values here, and we have a very, very high amount of people without diabetes, and then we have a small amount with diabetes, but that's 8,500, so that's still a good sample. And then we have a 91,000. So the data set is a little imbalanced, and one of the challenges with AI and ML is actually being able to get data that is somewhat balanced depending on the problem. Now, some models don't really, a little bit of a data imbalance, like this may not be too bad for a given model, and this may not be a problem. But if the model can't predict this class very well, then, or this, that the individual does have diabetes, then we may not be doing too well on the data side. So we may have to decrease the number of benign or people without diabetes to actually get this to work properly. But that's just kind of one thing to keep in mind whenever we're dealing with this data set. Okay, let's see if we can get right back on to fiddling with our stuff in VS Code. So now what we're going to want to do is go here to our script again. And remember, we're just splitting the data. And then we have our model, which I selected an XGBoost model. And this is kind of like one of those silver bullet kind of models that you can use. It's not part of sklearn, which if you're familiar with statistical models, and when I use the word statistical model or words, I mean a model that is not built like in a necessarily like a structure like a neural net. Some models are simply just maybe a system of formulas or some sort of data structure, kind of like a decision tree or whatnot. I don't consider a neural net, like or forms of neural nets as statistical models, but not everybody believes that. So that's just something to keep in mind. But continuing forward, we have our model, and then we have our fit, which is basically our train. So that's how our model trains. So we'll have to keep that in mind as we go forward. But what you'll notice is I'm going to actually just run this in the terminal by doing Python main.py. And we're going to run it, and then you're going to notice that there's an error. And it says data frame data types for data must be int, float, boolean, or category. When categorical type is supplied, the experimental data matrix parameter, enable categorical, must be set to true. So there's a few pieces here. We haven't really done any cleaning on this data. We just kind of split it, and then we called it a day. But what we're actually going to want to do is pre-process the data. And when I mean pre-process, that just means to clean the data. So, or to set it up for training. So what I'm going to do, the labels are already in zeros and ones, so we don't have to worry about the labels. What we will need to worry about is the features, because if you look, the features are actually in strings. So it's male and female, and then we have never, no information, and this goes for, I think it's the smoking history. Yeah, it's the smoking history. No info, never, current, never, no info. And this might actually be something that we can drop. We may even want to drop the no infos on smoking history. Because if we can't tell if the individual has smoked, that might be something that might be a red flag for the model. The model may not actually be able to determine accurately what's going on between a benign and somebody that does have diabetes. So there might be a red herring somewhere, and if I keep going down here long enough, we'll eventually hit a no info that has diabetes, and that could throw us off. And that's just something to keep in mind. But I'm not seeing. Oh, there's one. So as you can see, there's one with diabetes. There's no info on their smoking history, but it might be something that we need to do is to get rid of that data. But for now, I think we're gonna go ahead and just kind of do the typical stuff. We'll do we'll keep it as another label or a category. And what we're gonna do, and this is gonna seem kind of weird at first, but we're gonna do something called one-hot encoding, which we're gonna let pandas deal with it. So I'm actually gonna paste this on over because I've already kind of done this. But what we're gonna do is we're gonna get the pandas get dummies, and then we're gonna take in the data, and then I don't think we actually need to do this. This is kind of optional, but drop first, whether the kids are dummies out of the category by removing the first level. I don't think we need. We'll keep it. Why not? If it breaks something later, we can always go back. But this is going to actually go through each of the columns, and then it is going to go, okay, well, a female is 0 and a male is 1. Or it may be vice versa, depending on how it encodes. But we don't really need to worry about that. The model is going to worry about that. The model is going to want a 1 or a 0 for gender from here on out. And then for smoking history, we're going to get probably 3 categories. We're going to get a never, a no info, or a current, unless there's another. I am seeing a flaw with this data. That said ever instead of never. So that could be an issue. Hopefully there's no other ever or no other ones. But it might have multiple categories, and that's fine. That is kind of like one of those things where it's another intuition kind of deal where you may not actually know if there are flaws in your data. It's always good to look at your data and verify that the pieces are all put together. You may notice that there are some flaws with labels or categories or numbers. The numbers might seem a little inflated compared to the rest of the data, and it may be a part of it. It might be an outlier, but sometimes those outliers can't be measured to the rest of the data set. So, like if somebody was that had diabetes, and for some reason they had a really strange blood glucose level, but it was because of something that they were using to regulate their blood glucose even before diabetes, and it's caused by another issue. That could throw a red flag with the rest of the data set. So just something to keep in mind. But what this will do is this will actually pre-process the data for us, and it will clean everything up. So we don't have to worry too much about that. Actually, I think we don't want this. I'm going to put that away. And again, if we need to add it back later, we can. But so that's kind of our start here is the pre-processing. And then what we're going to want to do is run this and see what happens. And we may actually get another data issue, and that's very, very possible. But it looks like we didn't get any issues. We did get a warning because it says use label encoder are not used, which is kind of weird. But it seems like that's more of a user issue, which I think we can actually close. We could probably delete this and it wouldn't be a problem. But let's try it out. Maybe that'll get rid of the warning. You may be looking at this and being like, well, Cameron, I don't see anything. I really don't see anything at all. There's no output. Well, I think we know that something is going on. What we need is to actually verify that the model is training. And what we can do is, I'm going to do a print statement in this case. We're going to say model is trained. And we can save off this model in a little bit, and then we can actually use this model. But just to have like our sanity, I'm going to go ahead and print this just so you see it. But you may be asking, like, Cameron, how in the world is how are we going to get metrics on this? Well, all we have to do is use these callbacks here, these little functions right here, and these are pretty important. These are some of the most important metrics that you're going to get, especially this guy right here. This guy can be very deceptive. Accuracy. A lot of people go to accuracy and they're like, oh, well, my model is very, very accurate. Well, it might be very accurate. It may be very good at being able to pinpoint certain things, or it might be able to think that it's correct when it may not actually be fully correct in this case. Like, it may be getting a lot of false positives, but it thinks that it's gotten the correct thing. The F1 score is going to be what's super, super valuable for us. So let's go ahead and get these calls here. So what we're going to do is Oh, I found my mistake. So the problem was I actually didn't use the train at all. I didn't use it properly. What you need to do is to make sure that you actually, we're going to do y pred, and you're going to want to use the model. And then what we want to do is pass in the x test. So everywhere where I put, I think it was y test, what I actually want is y pred. Or not y pred, or you want the truth, which the truth is the test here, the y test. And then the x test is what we're using here. And one thing to keep in note, this test set is actually only 20% of our data. So that's what we're using here. And it should be, we actually want to make sure that we're stratifying based on the y, which the y is this guy. And the reason why you want to do that is to make sure that you're distributing the labels out properly. That's something that I've done in the past that messed me up, but just something to keep in mind. But okay, so now that's more correct. If we actually run this again, we should get our results. It is very possible that something breaks here. Oh, it's model.predict. I messed that up. .predict. Some models don't require you to do that. You just do model and then parentheses. But in this case, we do have a predict. All right, let's go ahead and run this. Some models are designed differently, and people do them in different ways, but typically you do have a predict. Okay, awesome. So that's pretty good. We got an accuracy of a 0.97, precision of 0.95, and a recall of 0.69. And it is, and I will preface this is very hard to do with real life data. And this may be very real data. I did just pull this off of Kaggle just to play around with. But sometimes things can get a little hairy whenever you're dealing with metrics and whatnot. So that definitely is something to keep in mind. But we do have something really important that we'll need to go over here. So now that we actually have these metrics, we will add F1 score next. One thing to keep in mind is what these metrics actually mean. It is kind of hard to remember, and I highly recommend you look at it, look at the formulas for them when it comes to what accuracy, precision, and recall is in a statistical manner, because I absolutely 100% forget every single time. I actually have them written down right next to me, just so I can tell you guys what they are. So you take the true positives and the true negatives on top and divide that by the true positives, the true negatives, the false positives, the false negatives. And this comes into play with the test set and being able to predict on that and how many false positives and true positives that you're getting. And again, these metrics don't always work with every model. Accuracy, precision, and recall may not work for some sort of estimator instead of like something that uses error, standard error, instead of something that uses like a classification problem, kind of like what we're doing here. Something like error could be something like guessing the age of an individual based off of their medical history. And you'll have to guess that number or get close to it using some sort of error. But that's just kind of a random thing to think about. Or what the temperature is going to be based off of certain conditions, and it may be a little off depending on how it goes. But yeah, so we have our accuracy, we have the precision, we have the recall, and the precision is going to actually be your true positives divided by your true positives and your false positives. So it measures how many of the predicted positives are actually correct. So this is a very important metric. Versus accuracy, which I don't even know if I gave you guys a definition for that one, but it measures how often the model correctly predicts both positives and negatives. So this can be skewed, especially if you're getting like not the correct values. So definitely keep that in mind. And for recall, recall measures how many actual positives were correctly identified. So that's why recall and precision are so important, because you're looking for actual true positives. So in this case, we have our accuracy, precision, and recall. And recall is true positives divided by true positives plus false negatives. So in the case that it may not 100% get it right, it might get some false negatives where it gets something right, but it's kind of on the edge about it, or it gets something incorrect. And forgive me if I said something wrong there, because there's a lot of different pieces. But again, make sure to double check me on this stuff, because I don't always get things right off the bat. So next thing we're going to do is actually get the F1 score, and we're going to get the F1 score. And the F1 score is very important, because the F1 score is a combination of the precision and the recall. So so a lot of people, it's like the harmonic mean of precision and recall. That's what a lot of people look at the F1 score as, and what it actually is. So what you do is you do precision times recall divided by precision plus recall, and you multiply that result times 2, and you should get an F1 score. And this is really good for like imbalanced data sets where neither precision nor recall alone like will suffice, because there are some cases where precision or recall, even accuracy will be affected. They just don't they won't work with the data that were provided. And again, this kind of goes back to that data set issue, right? Where you're dealing with an imbalanced data set. A lot of problems go away when your data is pretty balanced, but that's something that could happen in maybe a perfect world. So right here we have our F1 score, and we have our Y true and our Y pred. So we're doing the same kind of deal. We're going to take these, we're going to paste that right on in there, and the F1 score is going to be, it's like one of the most valuable pieces of AI and ML. So we're going to do F1 score, and then we're going to do F1, and then we're going to run this, and the model's going to retrain. We could, I think our random actually will prevent us from getting different metrics. But our overall F1 score is 80%, which is really good, because our goal is to get to a 1. So I definitely think that's really good for an F1 score. So that's kind of it for how you would go through a whole process here. We ended up not using that label encoder, so we did remove that. But that is what you would do to actually train a statistical model using AI and ML. Just using sklearn, XGBoost, using pandas, some of those libraries. we can get into, and this will require a lot of setup on my part, but we can get into things like PyTorch and TensorFlow. I am not an expert in TensorFlow. I would have to go and pull somebody else in to kind of help out with that. But if that's something y'all are interested in, please let me know, and we can make a video on that. But this is Cameron Pierce and the Pierce portfolio on how to train a model. What we'll have to do next is actually save off our model to finish off this video. Okay, I had to look it up really quick, but it is model.save, save model. So you save the model, and then we're going to do a print. I don't know why I capitalized that. But we're going to print model save. And then we do, I just saved all those data pieces. And then we're going to take the same kind of thing. We're going to take a model that's an XGBoost classifier. And then we're going to do, should be a model load, I believe. Model dot load model. And then what it'll be is model.xgb. And then we print model loaded. And you should be able to actually predict off of that. But we're going to run it, let it train again, and then we will see if everything works properly. Sweet. Awesome. So I think that's it. Model was saved, model was loaded, and here is our XGBoost model. And you can't see all the details, but it is there. And it was loaded. So thank you so much for watching. Hope you enjoyed, and I will see you guys in the next video. If you have any questions, please leave something in the comments below, and I'll try to get back to you. If you want to see maybe PyTorch or TensorFlow usage, or maybe even how to use models in your own applications, just let me know, and I can make a video on that. See ya.